Hi everybody. In this video, we're going to look at using the reverse product rule to solve linear differential equations. And this is where we have a differential equation in the form of dy by dx plus py is equal to q, and p and q are constants or functions, and this p would be our integrating factor. So the first thing we need to do is arrange this differential equation into this form. We have a dy by dx term, but we can see we've got a negative here and we need a positive. So we can rewrite this as plus the negative 3 tan x multiplied by y. So now you can see that this negative 3 tan x will be our p term, and the e to the 4x sec cubed x would be the q term. So our integrating factor comes from this negative 3 tan x. And the integrating factor is where we have e to the power of p integrated with respect to x. So I'll substitute this into p, and then we can pull out this negative 3 in front of the integral and integrate the tan x. And if we go to our formula booklet, you can see the integral of tan x is the natural log of sec x, because we know in this case that k equals 1. And because we're dealing with logs, we can move this negative 3 to the top using the power rule. So we get the natural log of sec to the negative 3x. And now the e and the natural log will cancel. So our integrating factor becomes sec to the negative 3x. And now we need to multiply every term in our differential equation by this integrating factor. And there's a couple of things we can do here to tidy this up. We can simplify the sec to the negative 3x tan x, and the sec to the negative 3x and the sec cubed x will cancel. So if we begin with this one, we know sec to the negative 3x is the same as 1 over cos x to the negative 3. We can flip this upside down with this negative, and this will leave us with a cos cubed of x. And 10x is sin x over cos x. So when you multiply the cos cubed x by the sin x over cos x, we'll cancel one of these with this one. So we're left with sin x cos squared x. And we know these two terms will cancel, so we're left with this will equal e to the 4x. Now, using the reverse product rule, the derivative of sec to the negative 3xy will give us all of this. So we know this will equal e to the 4x. And now we need to integrate both sides with respect to x, and that will cancel out this derivative. So we need to integrate e to the 4x with respect to x. And this will give us 1/4 e to the 4x plus a constant term. So to work out the general solution, we'll move this sec to the negative 3x to the right-hand side, and we'll get sec cubed x multiplied by 1/4 e to the 4x plus the constant. So this is our general solution for part A. For part B, we need to find a particular solution when y equals 4 and x equals 0. So we'll substitute each of these into our function for y. So we can say at x equals 0 and y equals 4, substituting these two values in, the sec cube of 0 will give us 1, and e to the 0 will also give us 1. So 4 will equal 1/4 plus c, and therefore c must equal 15 over 4. We'll substitute this back into our function for y, we'll substitute it back into here, and then we'll factor out the quarter. So we get y will equal sec cubed x over 4 multiplied by e to the 4x plus 15.